Hi friends, today we are going to learn how to repair a dead laptop motherboard. Okay, so you can see on the screen there are three sections: section A, section B and section C. The section A is called the bolt-in battery charging sections, where the two input supplies are connected. One is an adapter and another is a battery, and this voltage goes inside the laptop. Okay, these are the output junctions where the voltage goes inside the laptop. It goes to the different sections. This voltage is controlled by this two MOSFETs and this MOSFET number 5, and this is the controller chips who can manage this. All these are the MOSFETs. Okay, so the section B is called the always voltage section, which generate a 3.3 and 5 volt before laptop power on. In this section there are total 4 department, 2 linear regulators and 2 pulse width modulator. We are using here TPS 51125 chips. These are the pulse width modulators, side 1 and side B, 3 volt and 5 volt, and inside there is a pulse width modulator chips and 2 linear regulator. Okay, and section C, this section is responsible for power on the laptop. And this sections we can see there are mainly 3 component. One is called the PCH, another is the SIO, and third is the EC bias. Okay, so this 3 chips require a 3 volt to operate. They require 3 volt to turn on, so they should get 3 volt before power on the laptop. Now once I connect the adapter from this DC jack, if I power on the adapter, the voltage goes inside the laptop and the voltage cross these two MOSFETs, cross this current sensing resistor. Here is a current sensing resistor. The value of this current sensing resistor is 0.002 ohms, which is a very minor value to sense the current of the laptop. Okay, so when I connect the adapter, voltage goes like this. You can see in this animation, this is my first test point where I can check this 18 voltage across this current sensing resistors, and this voltage goes out. Okay, so this 18 volt goes next sections. This section is called the always voltage sections. In this always voltage section there are 4 departments, 2 pulse width modulator like this. You can see on the screen, this is a pulse width modulator and this is another pulse width modulator. This voltages comes before power on button press. This section generate a 3 volt and 5 volt, and there are another 2 voltages comes out from this section, that is called the 2 linear voltages, that is called 3 voltage linear and 5 voltage linear. Okay, so that means there are 4 voltages comes out from this sections. So once the 18 volt goes inside the chips, this chip is, we are using here TPS 51125. This 18 volt goes, the pin is called the V in pin or the B plus pin. 18 volt goes inside, and this chip send the 2 voltages out, that is called VREG3. You can see this VREG3, that is 3 volt comes out, and VREG5. Okay, so VREG3 volt goes to this here, it's called the SIO, and EC bias. This goes to SIO and EC bias. We have to check 3 volt at here at VREG3 pin. 3 volt, if this 3 volt is coming, then this IC probably okay. If 3 volt is not coming, that means this IC may be the faulty, so you have to replace the chip. Then this 2 pulse width modulators are here, and to turn on this pulse width modulator is require enable signal. Here is everything is in digital format, like 3 means high and 0 means low. So to turn on this pulse width modulator, this chips require a 3 volt enable signal. This 3 volt enable signal is get from either a SIO, or he generated himself from, it takes from this VREG3, and it depend on the circuitry. Okay, so this 3 and 5 voltage coming across at this capacitor. This is a VREG3. This voltage is called a 3.3 always, and here is a 5 volt always. Okay, so here we can see the 3 volt coming at the SIO as well as EC bias at pin number 8. Now the next is to turn on the SIO. The SIO requires basically 3 things. First is need a power. Second, he need the EC reset. The EC reset generated by this RC circuit, it requires 3 volt here, 10 millisecond delay, 3 volt. And the third is clock, 32.7 kilohertz oscillation clock. Either he generate by himself by using a crystal, or it borrow from the PCH. The next is, this is the power button. It's called the NBS on, power on switch. Here is a 3 volt here, and the power on switch is here, and this is called the ground. Now if I connect the 3 volt to the ground, it becomes 0 volt. So when I press the power button like this, it generate a 303 pulse at the SIO pin, this NBS on pin or power on pin. When he receive this pulse, SIO send one pulse. This pulse is called the PCH power enable, and he send this 3 voltage to the PCH because PCH not got the power as yet. So now after pressing the power button, the SIOs generate one pulse that is called the PCH power enable pulse to this MOSFET at gate, and this 3 volt here it goes to the PCH. See in this animation, this 3 volt going to the PCH, and this voltage we can check at this capacitor on the PCH. If this voltage is coming at the PCH 3 volt, that means PCH is getting the 3 volt. Okay, so the next is, once the PCH got the power, in a few milliseconds the PCH get another signal that is called the resume and reset. Now it's a 0 volt, now it's become a 3 volt. It got a resume. It's called the RSM RST. And if the RSM RST is not coming, if it is stay 0 only, that means the problem probably either in SIO or the EC bias. We have to flash the EC bias and check, or we have to change the SIO. If it is coming, this RSM RST is coming, that means my both the things are working properly. The next is, once the RSM RST is received, in a few milliseconds, SIO send another signal to the PCH that is called a PM power button or a DNB power on signal. This signal, it's 303, he sent one pulse 303. So this signal is saying to the PCH that key power button is pressed. Now we have to turn on the power. So what to do? He asked the PCH. He sent this pulse. Now the PCH respond, and PCH will send the 2 signal that is called a slip mode 4 and slip mode 3. Now this both the voltages are 0, both the signals are 0 here on the SLPS4 and SLPS3 pin. You can check on this SIO. This is called the SLPS4 and SLPS3. If it is a PCH is okay, and if PCH found is everything is okay, then he send this 2 signal that is called SLPS3 and SLPS4 signal to the SIO. Okay, it's become a 3 volt. See in this animation, you can check 3 volt at SLPS4 and SLPS3 pin. And if it is coming, that means your PCH is responding properly, is everything is okay, everything is going nicely. And if this voltage is not coming here after power on button press and after PCH received this PM power button signal, that means my PCH may be the faulty, then we have to replace the PCH. The next is, once SIO received this SLP, S3 and SLP4 signal, he is sending 3 signal one by one, that is called a suspend on, then system on, and then VR on. These all signals are now in 0, 0, 0 volt. After he has received this 2 signal, he send one by one signal like this, suspend on, then system on, and then we are on. And this particular pulse width modulator started turn on and they are running. After that, once he received everything, once he sent everything, the SIO received one signal that is called a IMVP power good. The IMVP power good, that means the VRM power good, that the core section is okay. Now all the power section is okay, and finally he will send one signal, and that signal is called EC power okay to the PCH. It's called EC power okay, or call the PCH power okay to the PCH. He's sending this signal. Here it should be a 3 volt. That means all the power supplies are okay. Okay, so in this way we can see how to check a dead motherboard, how to. So now we are going to check on the schematic diagram how the sequence works. Just now we check on the concept diagram how we are going to check the signals on all the voltages on the motherboards. Okay, and now we open a schematic diagram, and we'll see on the schematic diagram where we are going to check all the signals. Okay, so we are open this compile motherboard. This motherboard name is LA7981P. okay, and this is a 64 page diagram. In the second page, this is a block diagram. The CPU is, this one is a processor, Intel Ivy Bridge 3rd generation socket 988B, Panther Point HM75. This is a PCH, and SIO is a ENE KB9012 is a SIO. In this SIO, EC bias is inside this SIO. Okay, so we are going to check if this motherboard is dead, and what are the test point we are going to see now. Okay, this is a page number 2. In page number 49, now we'll go to the page number 49. This section is called the volt-in section. Okay, volt-in power in section. We'll zoom this section. Here is our adapter input. Okay, this is my adapter input. This is my adapter voltage, 18 volt or whatever it may be, 18.4 or whatever. So the voltage from here, this one is a MOSFET. MOSFET location is LPQ301 and PQ302. Okay, this one is a drain, this one is a source, and this one is a gate. This gate is controlled by this chip. This gate is controlled by chips. This chip's location number is, location number is PU301, and the chip number is BQ2472. Okay, so once he received, this chip is received the AC detect signal, he drives this MOSFET, this 2 MOSFET he drives, trigger this gate, and the voltage travel from this MOSFET is cross this both the MOSFET, and voltage comes across this resistor. This is my first halt. Here I should get 18 volt here. Okay, this location number is PR302. Location number is PR302. Here I should get 18 volt. If it is 18 volt is not coming here, then possibility either of this one of this MOSFET may be the faulty, or is not getting trigger from this chip. Okay, so here I have to check this voltages and this chip, and if the voltage is coming across this resistor, then this section is okay. Then we have to go to the next section, that is called the always section, that is on the page number 50. So we'll go to the page number 50. Now this is a page number 50, and this section will create a 3 volt and 5 volt. This sections generate of totally 4 voltage, 2 linear voltages, and 2 pulse width modulator. Okay, so in this location is a PU401, and this chip number is RT8205. It's similar to the RTPS 51125 just now we have seen our concept. So this is our pin number 16 is a VIN input where 18 volt is supposed to come. This VIN pin number 16 is 18 volt supposed to come when we connect the adapter. And if the chip is okay, then he send the two voltages out at the VRG 3 at pin number 8. Here I should get a 3 volt, and this VRG 5 pin number 70. Here I should get a 5 volt. Okay, and this 3 volt goes to the SIO. We'll see later on. And the next is these are some pulse width modulator, 2 pulse width modulator. You can see this is a pulse width modulator here and here inside the pulse, and this pulse width modulator enable signal to power on. Here you get enable signal, and once you get the enable signal from this pin, this section will start, and here generate a 3 volt always, and here a 5 volt always will be here. Okay, so in this way 3 volt and 5 volt is generated, and if it is not coming, then we have to check this section. Okay, and if this voltage 3 volt is coming out, this 3 VLP goes to the SIO, as well as this 3 volt always also goes to the SIO. The next section will go to the SIO, the page number 42. This is page number 42. My SIO location number is U31, and the SIO number is KB9012. This is my SIO number, and this 128 pin chip. First I had to check pin number 111, that is 111 pin. Here I should get a 3 volt, that is come from always voltage 3 VLP. And the secondly I have to check pin number 9, 22, 23, either of any of this pin I should get a 3 volt here. Once this chip get this 3 volt, then it will start function, but before that he need a reset also, that is called the EC reset. Okay, so this is a EC reset. You can see on pin number 37. This one is the RC circuit. Here is a resistor, 47 kilo ohm resistor, and this one is a capacitor, 0.1 microfarad capacitor, and here is a 10 millisecond delay. We'll get a EC reset. Okay, then this chip will start for function. Okay, so now the next is, once he received the EC reset, next we have to press the power button. The power button on the page number 114. We can find where it is. See, in the on off here, 114. This is the on off switch. 114. This is my on off switch. Here I should get a 3 volt, and when I press the power button, it goes to 0 and come back again to the 3. That means my power switch is okay. The next is once you receive this power on button, the next is this SIO send one signal, that is called the PCH power enable. Okay, the PCH power enable, that is called a PCH power. We'll find where it is. PCH power enable. See this one, 119 PCH power enable. Once the power on button is pressed, here I should get a 3 volt. If I get a 3 volt, that means my SIO is responding. 119 pin 119. Here I should get a 3 volt after power on button is pressed. That means the PCH will receive the 3 volt. The next is my PCH. This is PM power button, that is post power button. It's called the digital power button. It's called the DN power button. The next is DN power button. That is this one, pin number 106. Here I will get a 303 pulse after PCH power enable signal. The next is RSM RST, resume and reset. RSMRST. See, RSMRST. Pin number 100. I have to check pin number 100. After power on button press, I should get here 3 volt. If 3 volt is not coming at this pin number, that means possibility either my SIO is bad or my EC bias is corrupt. So I have to flash the SIO bias, EC bias first. If the problem is not solved, then I have to replace SIO. The next is power button. Okay, this PM power button 106. The next is when now PCH got the information that power button is pressed. Now the turn of PCH to give two signal to the SIO, that is called slip mode 3 and slip mode 4, that is called SLP-S3 and SLP-S4. Here is a SLP-S3 at pin number 6. I should get here 3 volt and pin number 6, and here is a SLP4 at, yeah, see, SLP-S4, PM SLP-S4. If I'm not getting a 3 volt here, that means possibility that my PCH may be bad. So I have to check PCH, and if it is voltage is coming, that my PCH is responding. 127 and pin number 6, SLP-S3 and SLP-S4. The next is my SIO will turn on all the voltages one by one. First he'll start system on, then suspend on, then VR on. Same signal like this, SUSP 116, then system on, pin number 95, and finally VR on 121. This signal come one by one. Okay, so after every signal as comes out, then the SIO will get the confirmation everything is okay, the VRM power good is okay. Then finally SIO send one signal that is called the PCH power okay. This signal from pin number 32, there is a final signal saying that all powers are okay, now proceed for the reset signal. So in this way we can check a dead motherboard, and if one of the signals is missing, then you have to check accordingly. Thank you very much.